Every second, thousands of people ask the same invisible question, not out loud but through a keyboard. Someone types, "How far is the moon?" Another searches, "Best pizza near me." Someone else wonders, "Why do cats purr?" or "Who won the game?" It feels like a simple action. Type a few words, press enter, and within a fraction of a second, millions of answers appear. Yet behind that tiny search box lies one of the most complex technological systems humans have ever built. A global machine operating silently while handling billions of searches every single day. Think about the last thing you searched online. It might have been directions, a recipe, or a quick fact for school or work. The result probably appeared so quickly that you barely noticed the time it took. But when we zoom out to a global scale, the challenge becomes astonishing. Across the world, people perform more than 8 billion searches every day, roughly 100,000 searches every second. Each search asks a different question, and each user expects an instant answer. The difficulty lies in the size of the internet itself. The web contains hundreds of billions of pages written in thousands of languages. These pages are constantly changing. New sites appear every moment, old ones disappear, and existing pages update their content. Some pages contain reliable information, while others contain misinformation or spam. Despite this chaos, modern search systems manage to identify useful results almost instantly. To understand how this is possible, it helps to return to the early days of the internet. In the 1990s, the web was still relatively small compared with today, but even then it was growing quickly and becoming disorganized. Universities posted research online, companies launched websites, and personal blogs appeared across the internet. However, finding information was extremely difficult. Searching the web felt like walking into the largest library ever built without a catalog or a librarian to guide you. Early search engines existed, but they were very basic. They mainly looked for pages containing the exact words that someone typed into the search box. If a person searched for "best cameras," the engine might simply return pages repeating the phrase "best cameras" many times. This allowed spam pages and low-quality websites to dominate search results. As the internet expanded, it became clear that simply matching words was not enough to organize such a vast amount of information. A major breakthrough came when engineers realized that the web itself contained clues about which pages were important. Websites often link to other websites, creating a network of connections. Each link acts like a recommendation, a signal suggesting that another page might contain valuable information. If many reputable websites link to the same page, that page is likely to be important. This insight led to the development of ranking systems that analyze how pages link to one another. One famous example is PageRank, developed by Larry Page and Sergey Brin when they were graduate students at Stanford University. Instead of simply counting keywords, their system evaluated the importance of pages by examining the structure of links across the web. This idea became a foundation for the modern search engine created by Google. However, ranking pages is only part of the process. Before a search engine can return answers, it must first discover the pages that exist across the web. This task is performed by automated programs known as web crawlers, sometimes called spiders. These programs constantly move from page to page across the internet. A crawler begins on one website, reads its content, records information about the page, and then follows the links it finds to other pages. Each of those pages is scanned as well, and the crawler continues exploring in every direction, because the internet never stops changing. This exploration never ends. New pages appear every second, existing pages are updated, and entire websites are rebuilt. Crawlers continuously revisit pages to keep their records fresh. In this way, search engines maintain a constantly updated map of the web. After discovering pages, the next step is organizing them. This information is stored in a massive structure called a search index. The index functions much like the catalog of a library, but on a vastly larger scale. Instead of listing books, it records details about billions of web pages, their text, titles, images, links, and many other signals. When someone searches for how to bake bread, the search engine does not scan the entire internet in real time. That would take far too long. Instead, it quickly searches through the pre-built index, which already contains organized information about the web. This allows the system to locate relevant pages almost instantly. The size of this index is enormous, and storing it requires a global network of powerful computing facilities known as data centers. These buildings, often as large as football stadiums, contain thousands or even hundreds of thousands of servers working together. Inside them, rows of machines run continuously, processing data, storing information, and responding to requests from users around the world. When you press enter on a search query, your request begins a rapid journey across the internet. It travels from your device to your home router, then through your internet provider's network, and eventually through high-speed fiber optic cables connecting cities and continents. Inside these cables, information moves as pulses of light traveling close to the speed of light itself. Some of these cables run beneath oceans. Massive submarine fiber optic systems stretch across the seafloor, linking continents together. Through these cables, billions of searches, messages, and videos move silently every day. Your search request may travel thousands of kilometers before reaching a data center. Once there, thousands of servers begin working simultaneously. Some servers search through sections of the in-detail, others evaluate page rankings, others filter spam or analyze your location. Within milliseconds, these calculations combine, and the best results are selected and sent back to your device. From the user's perspective, this process feels instantaneous. But behind the scenes, it involves enormous infrastructure and complex algorithms working together across the globe. The impact of search technology is profound. Search engines have become gateways to human knowledge. Students use them to learn new subjects. Doctors consult them for medical research. Engineers find solutions to technical problems, and travelers use them to navigate unfamiliar cities. Tasks that once required hours of research in libraries can now be completed in seconds. Yet search technology continues to evolve. Modern systems increasingly try to understand the intent behind a query rather than simply matching words. If someone searches for best restaurants, the system considers factors such as location, time of day, popularity, and user reviews. Artificial intelligence plays a growing role in this process. Machine learning systems analyze language patterns, interpret questions, and sometimes provide direct answers rather than just lists of links. Instead of simply pointing to information, search engines may summarize knowledge or provide explanations. However, these capabilities also introduce new challenges. The internet contains misinformation, spam, and manipulated content. Search engines must constantly evaluate the trustworthiness of billions of pages while preventing bad actors from manipulating rankings. The algorithms that determine what information appears first can influence what people learn and believe. As a result, search technology is no longer just a technical system. It plays a major role in shaping how humanity accesses knowledge. Despite these changes, the core idea remains remarkably simple. A hidden network of crawlers continuously explores the web. Massive indexes organize billions of pages. Data centers filled with servers process requests from across the globe. Fiber optic cables carry information between continents at the speed of light. All of these components work together every second for one simple purpose: to answer a question. Because every search begins the same way. Somewhere in the world, a curious person types a few words and presses enter. In that moment, a vast global system wakes up, scans this digital map of the internet, and returns the most relevant answers in less than a second. A quiet miracle of engineering repeated billions of times every day.